Okay. This is hydrates. What's a hydrate? It's water trapped. It's different than dissolving. It's different. It's water trapped. How do you get rid of the water? Heat it. The water evaporates. And then what's the thing called with what you're left with? Anhydrous, because an means without, hydrous for water. So if you want to figure out how much water is there, what do? You weigh it, you heat it, you weigh it again. And the mass loss is always going to be, assuming, water. Problems with the lab for that is you don't heat it enough, you don't evaporate all the water, you spill it, there's kind of some issues that can happen. So this says copper chloride when heated is dehydrated. Why do they give you this 100 degrees Celsius here? Because that's when water boils, so they're kind of making you think, okay, water. If 0.23 grams of CuCl2.x H2O gives off 0.185 grams of CuCl2 on heating, what is the value of X? What is X supposed to be?
The number of moles.
So it's the moles of water. That's what you're solving for. That's how you do a hydrate. Okay, we're given numbers here. What's 0.235 represent?
Total hydrate.
So this is the total. What's the 0.185?
Without the water.
So it's the amount left after the heating. So how do we get how many grams of water there are? Subtract. So I'm just going to take 0.235 minus 0.185. And after you subtract that, what do you get? 0.05. So that's 0.05 grams of water. Okay, next step for hydrates. And have you noticed most of these formulas generally have the same next step? If you're in grams, you go to moles. How do I do that?
You divide by the atomic weight.
So I take 0.185 grams of my anhydrous and grams of my water. Divide by the molar mass to get it in grams. So I'm going to get 0.0014 moles of anhydrous and 0.0028 moles of water. Now what? How do you solve for X? No, that's empirical. For hydrates, it's another thing. For X, you're going to do moles of H2O over moles of anhydrous. So in this case, it's going to be 0.0028 over 0.0014, and I'm going to get 2. So what does that 2 represent? The moles of water that are attached. Here's a question. How would you name this hydrate?
Copper chloride dihydrate.
So you name the CuCl2 part. You can either say cupric or copper 2. So copper 2 chloride, and then how do you do the water part? Di. So you use the covalent prefixes. Dihydrate. So it's copper 2 chloride dihydrate. Yep.
If we only rounded to 3 places in the moles, we got X equals 3, and then you saw it work.
Yes. Okay. Yes.
For the hydrates, is there like a maximum amount